Hey everyone, I think we're going to get started. All right, so Tim and I are here today to talk about Azure IoT Solutions and how to get you started building an IoT solution quickly. I'm Corey Newton-Smith. I'm a PM manager on the Azure IoT Solution team.
And I'm Tim Laverty, Dev Manager in Azure IoT Solutions.
So let's get started. On the agenda today, we have our talk broken down into 4 different chapters. In Chapter 1, we'll talk about what an IoT solution is and what the challenges are and complexities are behind building one. In Chapter 2, we're going to talk about how Microsoft is simplifying IoT through our 2 solution offerings, a SaaS offering and a PaaS offering. In 3, we're going to talk about the recommended IoT solution architecture. Tim's going to give an overview and drill into the IoT reference architecture that we just shipped a few days ago. And then in the last chapter, we're going to actually dig into customizing a solution accelerator through some code samples.
OK, so first chapter. I'm going to just kind of give an overview of what an IoT solution is. And really, at the heart of it, it's very simple. We have things that generate data. We're taking that data and we're building insights based on the data that's sent. And then we're taking action on the insights that we built. So at the heart of it, kind of keep in mind, like use that to ground yourself, that this is a very simple solution that we're building out. Then we start to layer on, like taking a more realistic view. We have to think about things like end-to-end security and device management and solution scale or high availability. And then we start layering technology on top. There are over 140 Azure services. Sometimes it feels like to me that updates to services or new services get released almost daily. So very, very rapidly churning technology landscape in the cloud space and definitely IoT space as well. And then 3, there's a set of solution-specific questions that you really need to ask yourself as you build out an IoT solution. How many devices are going to connect? How often will they send data? How big are those payloads? How long do you store that data? And then what kind of queries and analytics do you run over the top of the data once you've got it? These are each critical questions when you think about the design of the solution, the technology choices for the solution, and the cost of the solution once you finish your design. So now I have like a wet blanket over the space. I'm going to hand off to Corey, and she's going to talk about some of the work that we're doing to alleviate this complexity.
So like Tim said, at this point in the presentation, you may be thinking, oh, geez, Tim, you just told us all of the hard parts about building an IoT solution. But Microsoft's really trying to simplify the IoT space. And I'm going to talk to you about the 2 offerings that we have available to you today to do just that. The first offering that we have is called Azure IoT Solution Accelerators. And the second offering that we have is called Azure IoT Central. Solution Accelerators is a SaaS-based offering. It's an open source offering that is an end-to-end IoT solution that's meant to accelerate you by giving you examples of best practices and patterns. Most of the talk today is actually going to center around Solution Accelerators because they're targeted at devs like yourselves. However, it is worth mentioning that in both of these solutions, they're built on the same underlying cloud services and technologies. So when we look at something like Azure IoT Central, this is a fully managed SaaS-based offering. You can spin up a production scale offering from anywhere in the world, production scale solution from anywhere in the world, and you don't have to worry about any of the cloud infrastructure underlying it, or spin up a team to understand all the cloud technologies or big data technologies. So I want to look at these 2 solutions side by side to do a comparison in which solution you should use where. So Azure IoT Central is a great place to get started with a simple, straightforward solution. It's fully managed by Microsoft. They manage all the underlying services for you. You can use a web-based experience to customize that solution. And you don't have to have any coding skills to get started. On the other side of this chart, we have Azure IoT Solution Accelerators. The accelerators will really offer you maximum flexibility. So these are open source offerings that you can take and customize to whatever it is your business need may be. But as a result of being open source, you need to know either .NET or Java in order to modify the backends, and you need to know JavaScript in order to modify the front end. The great thing about both of these solutions is that they deploy in minutes, and so you can get started very quickly, which I'm going to demonstrate for you right now. Let me switch over to Tim's machine. So if you go to azure.com/IoT today, this is the homepage that we have on Azure. We have two kind of buttons down here. One is Try IoT Solutions, and one is Build IoT Apps. In the Try IoT Solutions is where you're going to find IoT Central. You scroll down here and you say Get Started with IoT Central. And then click this Get Started button. So here's where I'll be able to build a new application. In advance, I spun up this sample dev kit. Actually, Tim, we might need to delete this. 1 second here. I'm not going to be able to spin up a free app. So I can spin up a free app here. Oops, sorry. I think we need to delete this one, Tim. How do I go about deleting it? Where is it? Oh, here. Gotcha. Delete.
Thanks, Peter.
Thank you, Peter. I can only have one trial app, and Tim and I were clearly playing with this.
That was my fault.
In advance. So I'm going to spin up a free app here, and I'm going to do it using a sample dev kit. So go ahead and create this. So we have a dev kit called the MX chip. It's a super interesting little dev kit that I'll fork out to the website while this is spinning up. But after spinning up a trial app with the sample dev kit, it creates a simulated version of one of these MX chips. I can go over here and look at the chip's dashboard. In the dashboard, you can see that you're going to see simulated measurements start appearing here. You can see settings, properties, rules, and there's a dashboard for this chip as well. I want to demonstrate creating a new simulated event for this chip. I'm going to pretend that this chip has a button. And you can see I've very easily created this event, which is going to be triggered intermittently to simulate the fact that this MX chip has a button that's being pressed on it. I can see also that I can create a rule based on this button. So if I create a new rule here, I can create an event-based rule. In the event-based rule, I can call it button pressed. And I can set up a condition using that button event that I just created. And then I can actually set up an action. So when the button event occurs, it's going to send me an email. And then I'm going to save this. One of the other really cool things that I can do is I can go on over to this dashboard. In the dashboard, you can see that there are a bunch of different tiles here available for the simulated device, things that are doing max temperature or average pressure measurements, a little picture of the device, and actually the telemetry down here in a chart. If I turn this into design mode, I can actually add things to this dashboard very easily. I'm going to create a little eventing chart around the button that I just configured. And I'm going to make it visible, and then I'm going to save it. And you can actually see down here now, I have this cool little button chart. I'm going to give this a little bit of time to start creating telemetry, and I'm going to fork out to the MX dev kit. The MX chip is super cool. Tim and I actually have 3 of these to give away today as part of our presentation. It's a really great way to get started. You can buy them off Amazon. You can have them shipped to your house with Amazon Prime. They're $44, and it includes the chip and a set of sensors. It also has a little OLED screen on it for debugging purposes, and we'll show you the temperature values as a headphone jack and like physical buttons. And it's a really great little dev kit that we have actually tutorials around as well. So just giving us a little bit of time to go back here and then look at the measurements. So now you can see that the solution is spun up, and we're seeing simulated measurements here. On the bottom, you can actually see this is the button event that I just created. So I can see those coming in on my timeline. And if I go back to the dashboard, I can see something very similar with the little reporting chart that I just created. And if I were to check my phone right now, I probably have an email based off of this event. So that kind of concludes what I was going to show for Central. I'm I'm going to jump back over to the presentation. So that's kind of the conclusion of what I'll be talking about central-wise today. Peter in the back here is the PM manager of this project. If you guys have additional questions about leveraging Central for IoT solutions, please follow up with Peter. He's more than happy to answer any questions that you guys have. And we're going to kind of take a deep dive now into solution accelerators and how they can help you as developers. So from a solution accelerator perspective, we have 4 solutions available today, open source, for developers to take and extend and customize. The most popular solution that we have is called remote monitoring. You can think of remote monitoring as kind of the table stakes solution for most IoT starting places. It's a very horizontal solution that has IoT devices in which you can monitor, configure, manage, and maintain. The second solution that we have available is device simulation. Device simulation is kind of a testing-based solution where you can spin up very quickly a number of simulated devices to target at a cloud solution that you're developing. The third solution that we have is Connected Factory. Connected Factory is an example of a managed Industry 4.0 factory floor. And it's really a best practices and patterns example of how to leverage some of our open source OPC components. And the last solution that we have is predictive maintenance. Predictive maintenance is how you can learn to optimize your solution using Azure ML. It's a very specific example of how to leverage ML to do remaining useful life of an engine. So solution accelerators have several value propositions. The first of those being is that they can be leveraged across all of the phases of an IoT project. A solution accelerator is end-to-end, like I mentioned before. It comes with a set of simulated devices, and after provisioning, you basically get live telemetry into the solution in which you can use as a demonstration. Oftentimes, solution accelerators are used for demos for line of business decision makers to explain to them what IoT is about, especially remote monitoring, something that's very canonical across many different verticals. It can also be leveraged very easily for a proof of concept. So if you have a solution accelerator, connecting a physical device to it is very straightforward. In probably 5-10 minutes, using one of our tutorials, you can connect something like a Raspberry Pi or the MX chip like I just showed with Central to a solution accelerator today. Development is has obvious value proposition from a phase perspective. It's an open source solution. You can take and customize it. But not only can you take and customize the solution from demo, but you can also take it to pilot in production. We've really put a lot of effort into aligning our solution accelerators with a reference architecture that is scalable to production. The next set of value propositions is around Microsoft taking a lot of the heavy lifting off of the table. We want to provide a good base for you to build on top of, and we want to do that with best practices and patterns. And the last set of value propositions are around saving time by building on top of a proven architecture. Tim's going to talk a little bit later about the IoT reference architecture and how that ties to our work in solution accelerators. But really, you can take these solution accelerators and perform fast customizations and extend them to meet your customers' needs. There are 3 target personas that I want to talk about with solution accelerators. Obviously, the first one is developers like yourselves. Don't worry, you don't have to wear a sport coat in order to use a solution accelerator. But we do recommend that you look very intently at your monitor while you're making customizations, like this guy's doing. Solution accelerators offer complete flexibility. They are a proven architecture, and they're available in both .NET and Java, and they're open source. From an IT administrator perspective, we bring to the table fast orchestration and deployment flexibility through the use of ARM templates that are also open source. And from an operator perspective, we build out that nice application dashboard with solution accelerators where an operator can see asset visualizations, they can do maintenance scenarios, and they can also do device management. So now I'm going to jump out and do a demo of remote monitoring from a solution accelerator perspective. So this is the remote monitoring dashboard that you get after provisioning a solution accelerator. I want to show you what it looks like to provision an accelerator first, though. Oh. So if you go similar place, azure.com/IoT. In solution accelerators, because they're meant to be customized and extended, fall under this button, Build an IoT app, rather than Try or Use an IoT app. Here's the 4 accelerators that I just spoke about. I click this button to go to the accelerator page, and then click Get Started. I'm going to look at the remote monitoring example, but I want to show you how easy it is to deploy and get started. So we'll click Try It Now on remote monitoring. And it's working on logging me in. And this is what the provisioning form looks like. You basically have to answer 5 simple questions and then scroll down here and click Create Solution. In the interest of time, Tim has already spun up one for me to leverage. So this is what the dashboard looks like out of the box. In remote monitoring, we deploy an application for you that's operator focused. So from an operator perspective, an operator can see devices on a map. They can see alerts related to the rules that are configured in the system and alarms that may be triggering. They can see live telemetry feeds from those devices, and they can see a set of analytics. So as an operator, I can contextualize this dashboard down to something more meaningful as I'm looking to work against an alerting backlog. So here on the right-hand side, you can see that there's a chiller that has a pressure rule that's being triggered. In order to look at just chillers, I can actually leverage this filter capability and set of built-in filters for demonstration purposes to filter the dashboard down to just showing chiller information. You can see that there's a couple of chillers here on the map. I can drill in and see them on this Azure map here. And I can see the telemetry feed down here looking at the pressure values. I can see that, hey, one of those chillers actually does have a higher pressure value than the other. Let's take a deeper look at it by clicking Explore over here. By clicking Explore, it takes me to the Maintenance tab in the left-hand nav there. This is really a page that's focused on operators investigating issues that are happening in the system. An operator can tell others working in the website that they're actually looking at this issue by selecting all of the occurrences and clicking Acknowledge. And then after acknowledging the occurrences, takes a little bit, I can go down here and actually look at the values like I was doing in the dashboard. And you could see the pressure for this particular device is kind of hovering between 200 and 300, which is far too high. I can actually act on this device right in the dashboard using the built-in jobs functionality to run a method against the device to release that pressure. So here I can say emergency valve release, release, and I can issue the command. I can view the job status inside of this page as well by going here. But back in the maintenance page, I want to show you how I can stay inside of this page and actually see if my method call did anything for this device. So looking at pressure here, I should eventually start to see the pressure for this device decrease, which I am slowly seeing now. The other thing that operators can do inside of the system, so there we go, is look at all of the devices. So here you could say go back to all devices. As part of the demonstration, we provisioned 10 devices total, 5 device types, 1 device that's working well and 1 device that's working errantly and triggering an alarm. An operator can look at all the devices here, see, and also do the same actions on them by selecting them, going to jobs. They can see the details of the devices in a nice detail flyout. And they can also configure and add and edit rules in the system as well. So you can add a new rule very simply using this flyout, or you can edit an existing rule. That's kind of the extent of what I was going to show in remote monitoring. So let me jump back to presentation. So one thing that I wanted to point out is that there are customers that are leveraging solution accelerators today. One of those customers is Schlumberger. They're the world's largest oil field services company. They have over 100,000 employees, and they're actually leveraging our remote monitoring solution accelerator to monitor their well sites. The other customer that we have is Telefonica. Telefonica has actually modified the remote monitoring solution accelerator, and we actually recently accepted their PR to add mobile-to-mobile communication from their cloud to ours. So before I transition over to Tim to talk about the reference architecture, I want to point out that each of the solution accelerators are reference architecture implementations. The solution accelerators are open source, they're MIT licensed, and we would love to accept PRs. I also want to point out that we're not done in the solution accelerator space. Tim's team of engineers and my team of PMs are actively working in this space, not only to build additional first-party solution accelerators, but we eventually want to allow third-party solution accelerators to be added to the group that we offer. So please stay tuned at Ignite, our Inspire, our partner conference in July, because we'll have more information on solution accelerators and how we plan to accept third parties. And then I'll hand it over to Tim to talk about architecture.
Thanks. Okay, so 2 more chapters. This 3rd chapter, we're going to talk about the recommended way that we suggest that you build your IoT applications, or that you architect and design your IoT applications. In our last chapter, we're going to dive a little bit deeper into what Corey was just demoing and show how you can customize the solution accelerators themselves. So we'll make some changes in a number of areas with them. Before we go there, though, we wanted to walk through what we recommend in terms of the architecture for building your IoT solution. We publish a white paper, or Microsoft publishes a white paper that really lays out what I'm going to walk through over the next 7 or 8 slides. This white paper, I would definitely highly recommend that you read at least the first 7, 8 pages of it. It provides context for the IoT space. It provides an overview of the subsystems that we suggest you build as you build out your IoT solution. And it provides pretty prescriptive technology recommendations that we would recommend that you use per subsystem. So before I launch into that reference architecture, I want to have a couple of caveats here. Architecture and software design is a super contentious topic. You put 2 devs in a room, and you probably have 3 or 4 opinions in the room amongst those 2 devs. So there's a lot of opinion, and in most cases, with folks that I've talked to, they're right. They're right for their particular solution or their particular vertical, their particular situation. So I want to recognize that right from the outset. The other thing I want to talk about is this is maybe illustrated through a story. So a couple weeks ago, I was at HMI, which if you're not familiar with it, it's an industrial conference in Hanover in Germany. And a lot of our focus there was on our connected factory solution accelerator and its help in building an OPC UA compliant solution. But I talked with a bunch of customers there, and one particular customer, it kind of resonated with me from an architectural perspective and a technology choice perspective. And this customer was asking essentially this question, and I'm paraphrasing here, but essentially they were saying, hey, I'm a Java shop. I'm super comfortable and familiar, and I've repeatedly been successful with the SMAC stack. If I'm going to run that solution on Azure, am I good? Or am I going to have a hard time? What are the pitfalls going to be running under Kubernetes with Cassandra used for horizontal scale for storage? And the answer to that question was absolutely. Our job, or a core part of our job, is to make developers like this successful on Azure. And it kind of ties back to my first bullet here, which is your skills, experience, and your specific solution will change, or can and should change, the architecture that I'm going to walk you through in just a minute. We're prescriptive about technology choices, but if you're not comfortable with that technology and you're much more comfortable elsewhere, then you should change. You should change what we're recommending for your particular solution. And I didn't want to over-index on the OSS aspects or and so on. Really, this is really just about, hey, your experience, your skills, your solution really do matter, and they should drive your architectural decisions as well. Okay. So with those caveats in place, popping back to that first slide, this is simple. I've got things, I got to get the data somehow. I want to take that data and I'm going to generate insights off of it. And then I'm going to take action to change my business based on those insights. Okay, I probably shouldn't have come to this slide yet. Basically what we're going to do over the next 4 or 5 slides is we're going to start to layer on additional complexity and subsystems on top of things, insights, and actions. So this set of subsystems, I have yet to see an IoT solution that didn't need each of these. They all have devices. They're all sending data to some cloud gateway. Some kind of stream processing or rules evaluation is being executed on top of that data. The data's stored. There's some kind of business integration. This could be as simple as, let me see the data. I want to visualize it. It could be much more complex. It could be integration with CRM. A number of the scenarios Corey was showing just a minute ago tied into alarm generation, visualization of those alarms. I think you saw her acknowledge a number of alarms and then actually take action in executing a method on devices as well, she showed. And then typically, like Corey just showed, there's a UI. There's a UI and reporting tools for visualizing that data and then taking action on it. The UI box really could be, you could picture moving it over to the right a little bit, right on the bubble of insights and actions. Sometimes you might be just looking at that data and seeing what's happening with it. Other times you're actually doing something and taking action on it. Okay, core subsystems. Now I'm going to start layering subsystems on top of these and refactoring a little bit of them as well. Okay, so here we've added bulk device provisioning. I have tons of devices. How do I get them connected? Do I have to connect each of them individually? Wow. I have an IoT edge device. This is the intelligent edge. This is, I want to do some processing local, on-premise. I don't want to do it in the cloud. I want to do some of it local and maybe some of it later in the cloud. I also might want to do aggregation inside of this IoT edge device and then send my data up to the cloud in a batch. Data transformation is next. Data transformation is kind of funny, I think, because like by data transformation, what I mean is I'm sending telemetry data, and like an example is, say it's in a very deep hierarchy, and before I stream process it or before I store it, I want to flatten it. That's it. Like, it could be much more complex than this, but simple, practical example that I've seen a few times. That data transformation could be done as actually part of stream processing. It could be done previous to the cloud gateway, but actually in the cloud. It could be done on the IoT edge device, or it could be done on the device itself, especially if you own the firmware that's sitting on that device, obviously. It's a little bit hard to place that box, what I was after. You see that I refactored storage, I split it. We put warm storage here, we put cold storage here. Reasoning here is this cold storage, that data sticks around for potentially a really, really long time, maybe forever. Machine learning is running on top of that data. This warm storage, a day of data, an hour of data, a week, maybe a few months. This is data that is being actively queried, consistently visualized. It's warm. Okay, so next set of subsystems layering on top of core is here. Now I'm going to pull in a few cross-cutting concerns. Anyone building an IoT app, 100% cares about security. Eustace, I think I saw Eustace in the room. Eustace did a talk on IoT security earlier this morning. I would highly recommend that you watch that talk. Eustace is a IoT device security expert. We roughly think of security in kind of three main click stops, or three main phases. First phase is security of the device. Is the device who we think it is? And is it securely connected where we want it to connect to, edge or hub? 2, when data is coming off of that device, so the data is in transit, is it being transported or is it being sent securely? And then 3, once the data is there, it's inside of our storage, is it safe? And this leads us down a path of, say, encryption at rest and so on. Cross-cutting concern, though, across the solution is security. So anytime you think of any of these subsystems, that has to be one of the #1 questions that's asked, is it done in a secure fashion? 2 is deployment that I have on this slide. It probably should be deployment and maybe app framework is a good way to describe it. I need to get those bits up to wherever they're going to run, edge device or cloud. And we also have to talk about what framework are they going to execute in. The solution that Corey was just showing, we have Docker containers. They're either being executed on a box with, say, Docker Compose up or Docker run, or they're running underneath an orchestrator, like Managed Kubernetes, AKS, or Kubernetes, or DCOS. They could also be running inside an app framework like App Services, or Web Role, Worker Role, or underneath Service Fabric as well. So by deployment, I'm talking about how do you get your code up there to run, and what execution framework or application framework is it running underneath? Obviously, cross-cutting concern for what we're building. Third cross-cutting concern, HADR, and this is really talking about region failover. If my application needs to be up 24/7 and never have any risk of downtime, I need to be very careful that I have my application running across regions. If one of those regions is down for whatever reason, natural disaster or other, I need to continue functioning, and I need to have some kind of fallback mechanism. This is something that not everyone that we talk to, it's not a top concern for them, but it is a consistent ask as well. Okay, so we've got landscape of IoT subsystems. We've identified the subsystems. We've kind of built them out. We have some cross-cutting concerns that are running across those subsystems. So let's talk a little bit about technology recommendations for implementing these subsystems. One thing I did want to tie back to what Corey was demoing earlier is what we've built in remote monitoring follows this architecture. There are some slight differences, but it basically follows this architecture and follows the technology choices that we're espousing here. So if you want to see an example of a running IoT app using this architecture, using these technology choices, clone the repos. Everything is public. And if you can, then contribute to them. Okay, back to tech choices. We didn't pull technology choices out of a hat. These weren't a random decision-making process or kind of subjective. I really like working with this technology. It's fun, so let's recommend it for building IoT apps. That wasn't what we did. We use an analytical process to compare technology alternatives per subsystem. Some of the criteria was consistent across every subsystem. Roughly, these kind of map to cross-cutting concerns. There are some additional ones here. Security, perf, scale, cost. Simplicity is a fascinating one because what's really easy for Corey might be hard for me because we have different skills and experience between us. So when you look at our technology recommendations, keep that in the back of your head. These might not be the right thing for you or your team. That said, we've proven them, and they will work. And that's what our solution accelerators are in part showcasing. Okay, each subsystem typically has some set of unique criteria for it as well. And the example that Corey and I have on the slide here is warm storage. Here, warm storage, you really care about query capabilities for sure. We care about query performance. This is used actively for reporting and visualization. I can't wait 2 minutes for data to be shown to me. And this kind of leads to caching integration as well. So with that, this is basically the process that we use to build out our technology recommendations. And here I'm overlaying those technology recommendations onto the diagram that we were showing previously. So for Edge, we recommend you use IoT Edge. For bulk device provisioning, we recommend you use the device provisioning service. The IoT Hub for your cloud gateway, Azure Stream Analytics for stream processing. And I should say Azure Stream Analytics for complex rules processing. The thing that, and if you dig into the stream processing section of the reference architecture guide that I showed earlier, you'll see that for simple rules processing, you might incur maybe less complexity and less friction in using Azure Functions for simple rules. For warm storage, we recommend you use Cosmos DB or TSI. TSI is an awesome solution for querying aggregates or other statistical measures across many devices. And a little bit later, we're going to demo how to hook TSI up to the solution that Corey was showing. So we'll show actual data flowing into TSI. Cold storage, we recommend you use Azure Blob Storage and then Azure ML. Okay. Quick review of Arch, or takeaways for this section. We recommend you build on a cloud-native architecture. We recommend you build these subsystems independently. So that they can be maintained independently, deployed independently, and scaled independently. These subsystems, the technology used to implement one doesn't necessarily lock the next subsystem to that technology. Like, technology might be appropriate to be different across subsystems is something to keep in mind. And this kind of architecture gives you the flexibility to make that decision. I could be writing one microservice using Scala and Java, and another with C# if I so desire, using this kind of architecture. 2, I've said this a number of times, this architecture and these technology choices are flexible. And you could and should change them based on your skills, your experience, your vertical, for sure. And then the last thing I want to say is send us your feedback, please. We try to pull in as much data as we can from customers on building real IoT apps. We're obviously building reference architecture implementations on top of what we've published here that Corey was talking about. But we'd like your feedback. We'd like your feedback on how the architecture is laid out and your feedback on the technology choices that we're recommending here. It's a fast-moving space. Love to have your input. So with that, I'm going to hand off to Corey, and she's going to kick us off on customizing solution accelerators, which she was demoing earlier.
Cool. Thanks, Tim. One thing that I want to point out before jumping into the customization section is that I saw a lot of you taking pictures of the architecture slides that Tim was talking through. One of the things to note is that the last 10, 15 minutes that Tim was talking is basically the PowerPoint, active presentation of the reference architecture doc. So all of those diagrams are included in that doc at the AKA MS link. IoT ref architecture is the path for that. So now we're going to talk a little bit about customizing solution accelerators. But before doing that, I want to talk a little bit about what the underlying architecture is of the remote monitoring solution to give you some context into how those customizations will come to life. If you remember before, when I provisioned the solution, I went out to the website and I showed you what the provisioning form looks like. What's happening under the covers while you're provisioning a solution, in the 10 to 15 minutes that the solution is being spun up for you, we're laying down a set of cloud services and a bunch of microservices in a VM that constitute the end-to-end solution. You can see here that we're provisioning on your behalf into your subscription and IoT Hub, Stream Analytics, Cosmos DB, a web app, an Active Directory using AAD, and a VM with a set of microservices inside of it, along with a C# simulator that's going to be pumping that data into the solution. This is what the basic remote monitoring deployment looks like. You also have an option to choose standard deployment as part of the automated provisioning on the website. The difference between these two deployments is that in basic, we try to keep the concept count as low as possible. And we're really building that solution so that you can keep the cost low as well, so that you can build a really easy demo and you can also get your feet wet in the developer context. In the standard demo, in the standard deployment, we introduce an orchestrator, which we leverage Kubernetes out of the box, and then we deploy those microservices and Docker containers across a set of VMs for scale and reliability. So from a customization perspective, we think of customizations in 3 layers: application layer, microservices layer, and cloud services layer. I'm going to do a very, very simple demo for you in the application layer. It actually doesn't require writing any code, but it's often one of the things that we get asked for most in our solution accelerators, which is, how do I take the solution accelerator and just swap out the logo and the name of it so that I can sell it better to the line of business decision maker that I'm trying to convince that they should invest in IoT? So I'm going to jump over to Tim's machine and back to the solution accelerator that I was looking at earlier. So if I go up here to the settings menu, I can actually drop it down and edit the logo here. I've saved a little build logo out to Tim's machine, so I'm going to leverage that. And then I'm going to change the name of this to Build Conference 2018. And I spelled it wrong. We don't want that. And then I click apply. And you can see in the upper left-hand corner, you have the build logo, and we've changed the name of our solution. So jumping back to the presentation, Tim's going to run us through the microservices layer and the cloud services layer customizations. There you go, Tim.
Cool. OK. I'm going to do 2 demos. And I'll walk through like one of the common themes or common asks that we get kind of tailing off of what Corey said when folks are looking at building a new IoT app is, do I have to connect my physical devices before I build the app? We ship a simulator that ships with remote monitoring. So when you execute a deployment, the deployment that Corey was just talking about, we're simulating those chiller devices, those elevator devices, those engines. So what does it take, and is it possible for you to simulate your own device? Like, I don't care about the chillers that are in remote monitoring. What's interesting is your stuff, and what does it take for you to model a device and actually see that simulated data, including what the telemetry patterns look like and telemetry payloads look like. So what I'm going to do is I'm going to walk through a relatively simple example of modifying the simulator or feeding the simulator a custom simulated IoT device. Roughly, a way to think of this is up on the board right now you see, or on the slide right now you see your IoT hub. There's a microservice inside of that microservice VM that is, it's a Docker container and it's executing and simulating these devices. What I've done in one of my deployments is I SSH'd into that basic deployment, so into the VM, and I stopped that microservice. So I Docker stopped that particular Docker container. And what I'm going to do is I'm going to run the simulation service local on my machine. So I've configured the simulator running inside of Visual Studio, it's a C# project, to point to our IoT hub for this particular solution, and we'll see it generating data for that IoT solution. OK. So this is the solution that we're actually going to send data to. There's no telemetry data right now because there's no simulator running. There are no alerts or alarms generated. There are no analytics or KPIs because there's no data coming in. I actually haven't created any rules for the data for once it does come in, so we won't see those. But what we should see at the end of this is we should see simulated data coming in for this new custom device that we're going to build. OK. So I want to simulate a light bulb device. And in order to simulate a simple light bulb device, I need these 3 files: a JSON file, a state machine file, and then a set of JavaScript files that represent the methods that that device supports. I want that light bulb device to support a turn on and turn off method, so that from my phone or from the web client that we were just looking at, I can call down into that device and say, hey, turn off or turn on. Okay? So let's take a look at what these files look like. So the file that's usually best to start with is this JSON file. And scrolling to the top of it, and I'm gonna zoom in, so this might feel a little bit disconcerting for a second. It'll be easier to see. So scrolling to the top of it, we see a schema version. We see an ID. This ID is what's used to tell the simulator the kind of device I am. That's how the simulator is going to identify the device. We see a number of default properties. Notice that we have a default property for temperature that feels like telemetry. And then this one is really critical, is this piece of JSON right here. So what this is saying is, hey, every 10 seconds, I want you to execute this JavaScript file, which is the state machine file. And we're going to look at that particular JavaScript file in just a few minutes. But that state machine is running inside the simulator, and it's updating telemetry values, so the local telemetry values. Something else is going to send the telemetry up. But think of them as 2 different threads or 2 different processes. You have a state machine updating the temperature. This could be very complex. It could be looking at temperature, humidity, speed. I have a motorcycle, a set of files that Troy, one of the PMs from Corey's team, built that simulate a motorcycle. It's pretty cool. And it's running a very complex simulator across many different sensors. Okay. Scrolling down a little bit, we see some default properties for the device and tags. These map to IoT Hub tags and IoT Hub reported properties. And then it starts to get interesting down here, where here we have, hey, how often are we going to send telemetry? Every 10 seconds. What's the format of the payload that we're going to send? JSON, and what is the message template? So it's going to look like temperature, value, temperature unit, the temperature unit. And then last, we have this cloud-to-device methods. What this is specifying, there could be many, many methods. And if you look at the, if you clone the device simulation GitHub repo, you'll see that we have our chillers, our elevators, prototype device, et cetera. They implement a number of other methods, including reboot, simulation of firmware update, and others. In this particular case, very simple method. Turns the light on, turns the light off. So let's take a look at the state machine. So remember, this JSON file is kind of the device model and the metadata about the device. So picture yourself taking this light bulb file and altering it for your particular device. Our state machine in this case, again, relatively simple. This main function executes every 10 seconds. All this function is doing is it says, hey, if the device is online, randomize a value somewhere around 75 for temperature. That's all it cares about. If the device is not online, just set temperature to 0. You could probably make this more realistic. There is state here, so you could say like, hey, if it was on within X minutes, then let's start dropping the temperature down in a curve so it reduces it more slowly. This is super simple. If the device is on, somewhere around 75. If the device is off, it's 0, and that's it. Okay, metadata file, state machine file, method implementation. Here is the method implementation for turning the light bulb on or off. Again, relatively simple. All we're doing here is we're saying, hey, if it's on, turn it off. If it's off, turn it on, and that's it. You can see a few logging functions sprinkled through here just that I placed in as I was debugging, creating the device. I wanted to show something simple because this is a really good base to start with as you dig in and want to simulate your own devices and see your own device data flowing through the solution accelerator, the remote monitoring solution accelerator that Corey was showing just a few minutes ago. Okay, I built the files. How do they work? So I'm going to open up the device simulation project, which is here. Inside of this device simulation project, there is a data folder, and it has a set of JSON files, which are those metadata files that we were just looking at. I already copied that light bulb JSON file into this folder. It's the exact same file. Like scrolling up, you can see temperature, you can see the state file or state machine JavaScript file reference, and also the method implementation file here, and telemetry spec. If you look under the scripts file, here we have our state machine file. So we've got our state machine file, and we've got our method implementation JavaScript file as well. That's it. Building this JSON file, building the supporting JavaScript files for state machine and method implementation. They plug into the code base, and the simulator will simulate them. I've already configured this particular code to just simulate one light bulb. That's it. So if we run this, remember a little earlier we had, or I showed this dashboard UI. So right now there's no data. What we should see within a few minutes is data flowing in telemetry. And here you can see the simulator starting it up, or starting itself up. It's configuring itself for different hub parameters, meaning am I running against what SKU of IoT hub, an S1, S2, or S3. It's smart enough to throttle itself so it doesn't overload the IoT hub that it's running against. And here you can just see kind of the debug spew of like, hey, it's loaded up. I'll pause it for a minute so we can take a look at what it's doing. It has this send telemetry thread that's sitting here sending telemetry. And it has this update properties thread that's pulling property values from the hub. And I'll let it run for a few minutes, and then we'll pop over to the UI and make sure that telemetry is flowing into the application. I hope.
It's going somewhere.
Yeah, it's going somewhere, that's for sure. Yeah. So what happens to the telemetry data is sent up to the hub, and then it is stream processed using Azure Stream Analytics. The rules that Corey was describing earlier, Azure Stream Analytics applies those rules to this particular telemetry stream. I don't have any rules set up for this particular light bulb device. So basically, the data is passed through ASA into Cosmos DB almost directly. So very, 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 very straightforward. Okay. Okay.
There you go.
That's good.
I wasn't going into a black hole.
Yeah. Our simulator is running. It's sent data up to the hub. It's passing through ASA, and it's being shown inside of our temperature telemetry chart here. Again, this is open source code. Like, the reason that these are here is for you to take them and modify them. What I wanted to show is just an example of a small change to one of the microservices to show telemetry being passed through. Okay. Pardon? Let me hold that thought for a few minutes. Let me get through the rest of the material, and I'm happy to walk through the GitHub repos and where the GitHub repos are and how you can clone them. They're publicly open source available, but let me walk through the last customization I've got, and then we'll open it up for questions, and we'll come back. Okay. Back to Corey's machine.
For one slide.
Yeah, for a sec. All right. I was going to zoom in here and show what I was going to add in terms of TSI, but it's too risky.
It's like having a third arm down there.
Exactly. Okay, so I have this hub. It's passing data to Stream Analytics. It's pushing into Cosmos. I want to add time series insights here. Time series insights gives me a way to run aggregate queries across many devices and other stats measures. It's awesome for it. So what I want is I want the data to flow into TSI. And it's fine if it keeps running through ASA and into Cosmos as well. But I want to add TSI to this picture. So picture me drawing like a little red box above IoT Hub and an arrow running from the hub directly into TSI right now. Okay? I don't know if it was worth switching machines just to say that. Okay.
Can't draw on it.
Okay. I have a deployment. This is a regular, pretty vanilla deployment. I want to add TSI to it first. So the first thing we'll do is add time series insights, time, not Tim series insights. And we're going to add a time series environment into our resource group. All it's going to do is add it. It's not going to configure it for us. So here we've kicked off adding the TSI environment into our resource group. In a couple minutes, I'll show you how to configure it so that it's pulling data off of the hub. And then we'll look at visualizing the data that's flowing into TSI. So here it successfully deployed the environment into our resource group. And the way that you configure a TSI instance to point to the hub that remote monitoring deployed for you is you go to event sources. Notice no event sources here. I say add. And here it's going to ask me how I want to configure it. I'm saying I want this to use an IoT hub. I've named it, and I told it to use an IoT hub here. I'm going to pick my subscription. And I'm going to pick the IoT hub that I actually want to pull data from. One of the things to recognize that you need to be careful of is the IoT hub exposes a set of consumer groups. These are, I think of these as basically queues. And for TSI, we want to have a single owner. So a single IoT hub consumer group for TSI. And here, I actually already created one earlier on the IoT hub, this TSI consumer group. And I'm not actually going to click create right now because it takes about a minute for that data to start flowing into TSI. Earlier this morning, I deployed a TSI instance and did exactly this. And I want to show you the Explorer so you can actually really see what the data looks like. So if I come back into our resource group here, I see this build time series insights environment. And you also see that it has an event source that's already pointing to the hub. That event source is pointing to that hub consumer group that I earlier created. So if I open up the build time series environment, I'll go to event source really quick so you can see it. And you can see what it looks like. Here I've created that hub event source. If I come back to overview, in this upper right corner, we see this time series insights Explorer URL. This URL, it's a time series supports a set of JavaScript controls, which actually we use inside of the remote monitoring solution Accelerator. Time series also supports this Insights Explorer functionality standalone, and it's super cool. So what it basically does is it's facilitating anomaly detection. It's facilitating kind of a deep dive into data, and I'll show a starter of it here. So here's my time series insights. I'll follow Corey's demo earlier and say we just want to look at pressure. We know that chiller 2 inside of the solution we were looking at had problems. So I'm just looking at pressure here. And I want to split that data by device ID. So what I want is I would like the time series Explorer to show me all pressure values and split it by device ID. So I look at every device that's sending in pressure telemetry. And pretty apparent right off the bat that one of these devices has a problem. Here we're looking at chiller 2, which is much higher pressure. Here's chiller 1, and then these prototype devices are in the mix as well. I can also look at a heat map of that data. What this is essentially doing is walking across like devices and doing some default anomaly detection for you. So it's showing you, hey, chiller 2 looks very, very different from the other devices that are sending pressure. And then the other thing is it's sampling the data for us as well. So it's saying this is average of chiller 2 for this particular time frame, doing that across devices as well. Okay. So that is how to take time series insights, add it to a deployed version of the remote monitoring solution Accelerator, wire it up to your IoT hub, and then visualize the data coming out of it. Okay, some takeaways and call to action for everyone. Kind of like we said, at the heart, it might be simple, but building an IoT solution, it can be complex and challenging. We offer a couple solutions to facilitate building those solutions: IoT Central, our SaaS offering, and our solution accelerators, a few solution accelerators across a set of verticals. We recommend as you build out your IoT application or IoT solution that you use our reference architecture to guide you in laying out your subsystems and your technology choices with the caveats that I mentioned earlier. And then last, I would ask, like this gentleman over here was asking, I would highly recommend that you deploy our solution accelerators, take a look at the code, and dig into them. A couple other things, just for reference. We have an IoT show. Olivier runs this. It's great. It's about a 15 to 20 minute videos that happen every week. And they kind of take snippets out of the IoT space. It's a really good way to learn that's quick. We're also booting up an IoT school with similar kind of objective of taking these kind of bite-sized chunks and learning about IoT. Number of sessions, and I know we're tail end of the conference, but everyone here, all of these are recorded. I would highly recommend taking a look at them. And then last, like we said, we recommend that you deploy solution accelerators, and we have a host of tutorials and templates for how to make customizations to those solution accelerators to try to get you bootstrapped, where to find the repos, where to clone them, how to make customizations to them as well. With that, we're happy to answer any questions that the group has. We have about, I think, 14 minutes. And I think let's go ahead and use the mic. That way we can track everyone. We can make sure we hear you all.
Hi, this is Rick from Johnson & Johnson Medical Devices. So first of all, I must tell you, this is extremely valuable because this helped us evangelize what my group does within J&J. So thanks a lot for that. We are also engaging Microsoft CSE to help us build additional capability on top of this. So I had a couple of questions. One is that, and maybe this is my lack of understanding of how tiers work, but IoT Hub has a free tier, which has 8,000 messages per day, right? I don't see that option when I try to select that, right? And neither can I downgrade once I have created an IoT Hub. So why do we not have a free option when I create that? Is that I understand that might be a certain intent, but I'm just curious why.
You or me?
I can answer based off of what I know. So, I mean, we have a free tier in IoT Hub, and the challenges with it today is that it's not upgradable and it's not downgradable too. So for us to leverage it for something like solution accelerators would be kind of a dead end for people, and that's why we don't leverage it out of the box. I mean, that's the short answer to your question. There's not really a longer answer.
Would you be open to consider a change?
Here's the other thing I'd add to what Corey said. I am totally with you. The other thing I add to it is there is a basic tier, which is comparable pricing to event hubs. It's very cheap. You could change your IoT hub to a basic tier or deploy to using a basic tier hub.
The biggest limitation with basic tier is that it's just single direction. So it's only telemetry up, no commanding down.
Yep.
Okay.
Right?
No device management.
So that's something fairly new that we do have that that is a fraction of the cost of the lowest S1 tier that we have in Hub. And it is a way that we recommend that people get started in scenarios where they don't have commanding on their radar immediately.
Okay.
But that's kind of the solution that we have today.
Like the other thing I'd say is like we did build the solution accelerators with the intention of getting you started quickly and cheap, like not spending or not costing you a lot. And it's pretty hard to show a solution that stays under that 8,000 message cap that is reactive and shows the kind of telemetry chart. So what we ship does use an S1 with 1 unit. So I think it starts at like $250 per month.
Okay, all right.
Cheapest,
I have another quick question. So if you go to your devices tab, there's a thing on the top called SIM management. And that excites me a little bit because, so I don't know whether when you say SIM, it's a subscriber identity module or whether it is simulation management, but we are into cellular. And when I see
it's cellular
something,
management,
Thank you. So what is, can you tell me more about it?
Yeah, so this is the place where Telefonica has done their integration. And we just took their PR back into our GitHub repository. And what you'll find under SIM management today is basically a message to contact Telefonica so that they can do a little bit of back-end work to enable their SIM to connect to our cloud. But once kind of doing that handshake, devices using a Telefonica SIM can hook to the remote monitoring solution. One of the things to note about SIM management is that this interface itself is also open source, and so like you could port effectively the same thing that Telefonica has done across other mobile providers in a similar way.
Okay. So the last I checked, it said coming soon.
Yeah, and this is where Telefonica has done their integration here very, very recently. So if you check the latest one that's deployed, you'll see the Telefonica message.
Okay, excellent. I'll be very excited to do that. Thank you.
Yeah, and the other thing that we'll get integrated with SIM management from a SIM perspective is that when I clicked the devices and you saw that device details fly out, one of the things that integration points that they made was to show the SIM properties there and to allow bidirectional communication and changing of those, which is something very valuable. It provides kind of a single pane of glass so that you can manage not only the device and its telemetry and property characteristics, but also like its connectivity characteristics as well, right?
Okay, excellent. Thank you so much.
Yeah.
Thanks. I wanted to answer the GitHub repos question. Is that cool? Okay. I have open here the remote monitoring.net repo. If you switch this to Java, it would push you to an analog repo. It's the exact same submodules. This is the top level repo. It has submodule links into each of the components that we ship. If you take a look at what I was showing earlier was device simulation, which is this submodule. I cloned that repo separately, and I actually cloned the storage repo because device simulation uses our storage microservice. But these repos, we've put a fair bit of work into building out a wiki that lays out the solution architecture of the solution and documents the public-facing API surface. What was I going to say? Oh, the READMEs, we've tried to bootstrap you to help you really get started. So these help you walk through, like, okay, like how do I clone the repo? How do I get things running? So I wanted to mention it. We didn't have it part of the talk, and it was one of the questions earlier. Is that great? Cool.
We also have complimentary docs on docs.microsoft.com. A lot of the tutorial content is up there. A lot of the developer-focused content is on GitHub about setting up your deployment environment and your development environment. Cool.
So I have a quick question about the IoT Central. Respectively to the accelerators, is there command sending down from the IoT Central, or is that only on the accelerators?
Accelerators have commanding. Peter, does Central have commanding down?
Device management.
Device management commanding down. His question is about Central's command and control. Very soon. Very soon.
Okay. The second question is, I saw the mapping on the accelerators. Is that also in IoT Central, the map control?
Soon.
One thing to note is we do use Azure Maps, which just went GA this week as well.
Yeah, so it's a great code sample of how to integrate with Azure Maps too.
Can I ask how soon?
You can.
You can. Just short will answer you.
Nothing is preventing you
Yes,
from
sir.
doing so.
Thank you. Is there any plan to support multi-tenancy for this? I have a project where we have different clients sending that up. So we want to have them seeing their own data, not each other's one. So I'm not sure if that's the case right now.
So there would be a couple of ways to do that. One would be to basically have to modify the storage endpoint so that you're storing that data separately, or to use roles. We have a work item in our backlog to introduce user roles, where you can actually say that, like, if you're a user of this type, you can only see these devices and therefore only their data. Those would be the two ways that I could think of. Did you think of any?
Yeah, we get asked. I'd be great to talk to you offline if you have a few minutes to kind of double click on what it is. I'd like to understand what you mean by multi-tenancy. Whether you have many customers from different companies coming into the same application, or yeah.
Yeah, and if you want to leverage the same services across them, or you're okay having independent services, but you just want to tie them together, there's some details that would help us better answer your question.
Okay, sure.
Yeah, cool.
Thank you.
Yep. Yes, sir.
Hi, yeah. Question on deploying the solution accelerators. Is that built into like an ARM template now if I wanted to customize it?
Yeah. So you can deploy from the solutionaccelerators.com site that Corey was showing. You can also deploy, we ship a CLI, our command line interface, so you can go to Bash or just Windows command prompt and deploy a solution. Behind it is an ARM template, and it's just laying out, here are the Azure resources I want. I want a VM, I want a hub, I want ASA. Mm-hmm. There are also a couple extensions that we use to configure the resources that we push out.
So that's all on GitHub?
Essentially, ARM
Yeah, it's all
template
on
plus
GitHub,
plus. is the gist.
Yeah, so the two deployment options are like leverage the CLI, the Solution Accelerator CLI that we have on GitHub, or leverage the website to do it on your behalf.
There's also a developer guide that we publish that if you didn't want to use solutionaccelerators.com, you didn't want to use the CLI, then we have a developer guide that walks you how to do it yourself.
Gotcha.
Like what I did here is I cloned both those repos, the simulation and the storage repos, and I just configured them manually. I used project properties to configure the environment variables that the microservices need and went at it like that. And
You
can
just
do it like
manually
that,
deploying every service and wiring it up.
Yeah.
to the
I
guide.
mean, if you're a dev and you want to run everything local, the CLI does have a local mode where it'll set everything up for you local as a one-time shot, which is pretty nice because like one of the disadvantages of this kind of microservices distributed system architecture is you've got a lot of moving parts.
Right.
Where in the past you might have just had one monolithic project, which had its own disadvantages of coupling, but
Right.
like having help configuring all of those services is kind of nice, and that's why we added that local mode to our CLI.
Okay. One other question. Do you have any reference architectures around offline or intermittent connected scenarios? Or
Not yet.
okay.
And that's a consistent ask,
Okay.
especially with the prevalence of the intelligent edge, IoT edge, the demand for on-premise processing, not just a gateway for forwarding, but that on-premise processing. It's certainly something that there's a lot of discussion around it, and we will be updating our reference architecture doc to cover it. We do talk about it in there, but it's not. I wouldn't call it baked yet, and I think over the coming months there'll be updates to it.
Okay.
Yes.
Hi. As you mentioned, these solutions may get pretty complex. Do you ship any tools or recommendations for monitoring the health of the overall solution with your accelerators?
I'll let you answer that one.
We don't ship anything that's solution specific, and monitoring and logging, like an aggregate log viewer, is something we do get asked for often. And we do have on our backlog to deliver. There are some built-in tools. Masashi was sitting in the middle of the room a little bit earlier, and it looks like that he stepped out of the room. But his team has done some work around, you can use the Azure dashboard to do a pretty good job of monitoring each of the Azure services. So you look at the hub, ASA, the VM. What it's not doing is it's not allowing you to kind of double click into a specific microservice or into the VM and give me the Docker logs from all of the Docker containers running in that VM and aggregate them together so that I can see kind of an end-to-end story. So I guess, like, in short, not yet. Definitely recognize the need. I would love to get a card from you because I'd like to talk about what you'd like to see. It would help us. It would help direct us in actually what we go build over the next 3-6 months.
Okay, thanks.
Cool. Thanks.
And I have a quick question. In the beginning, you mentioned about the device using OPC. Do you have an example for that situation?
So the OPC components that our team in Germany produce today that are open source are a proxy and a publisher that's integrated into the Connected Factory Solution Accelerator. So really, these are mechanisms that sit on the edge in the simulation that help communication between those OPC servers that are deployed in their virtual factory up to the environment in the cloud. And so these are the examples of the OPC connectivity that we have in solution accelerators today.
Okay, so where can I find that kind of example?
The Connected Factory example?
Right.
Yeah, so if you go out, like in the same web portal where I deployed the remote monitoring solution, you can actually see the Connected Factory one right on the side of it, and we'll pull it up here.
Also, down in the booth in the expo,
Yeah, there's a Connected Factory.
If you find IoT Central, all the rest of the IoT, there's actually one that has a wall full of OPC devices. There's a bunch of people down there who have
Both
Yes.
those are great. If you want to look at the code, press 7.
7? You can see
It's right there. It's, again, just like all of our solution accelerators. It's public, it's OSS, it's MIT license. So if you want to see an end-to-end running example, that's it.
Yeah. And all the documentation will be in the same spot as the rest of the solution accelerators on docs.microsoft.com for Connected Factory.
Yep.
Hi. So with the presentation today, it was clear that how we can go about building IoT solutions. However, when we have to deploy it at large scale, how do we scale such solutions? What should we consider during scaling?
The solution that we actually deployed today, both Corey and I were demoing basic deployments. That basic deployment, single VM. All of the microservices are on it, not built for horizontal scale. Using our CLI, you can deploy a standard deployment. It deploys a set of worker VMs running underneath a Kubernetes cluster. And then from there, you can dive in and configure Kubernetes to run as many VMs as you want and run as many container instances across those VMs. So what we showed today is it's in part, it's built to demo. Like it's in part built to showcase like, hey, here's how to build a simple IoT solution and here's how to see it running end to end. But it's also built to showcase a production-ready app or a production-ready solution. So what we built will scale horizontally. It will scale underneath an orchestrator. And I should say, like, it doesn't have to be Kubernetes. Sometimes people get excited about us talking specifically about Kubernetes. It doesn't have to just be Kubernetes. You could run under Service Fabric. It'd be fine. There's container support here. You could run under DCOS. You could run under Swarm. We could talk about running the microservices, running under app services, and so on. Did that answer your question?
So as a follow-up, actually, I understand that the VMs can be scaled horizontally. My question was on IoT Hub. Let's say the number of messages. Let's say there's a product in the market, IoT product, and more products are getting sold, and the number of messages will keep increasing.
Yeah.
So how can we scale such a scenario?
I hear you. You can go to, inside of the Azure portal, you can reconfigure your IoT Hub without creating a new one. So I can go in there and change it from there are three basic tiers, and then there are 3 standard tiers. There's a S1, an S2, and an S3. And there is the capability to specify how many units per or inside of S1, S2, S3, which will scale up your message cap. We don't limit the number of devices that are connected. What we limit are the number of messages that you send. This is really what it's about.
So which means that it's manual scaling and not auto scaling. Am I right in saying that?
Yeah, what the IoT Hub would do today is once you pop over that message cap, it will throttle you. And it will come back and it will say,
So it doesn't
sorry,
auto-scan, yeah.
you can't send any more messages. And what you would need to do is go to the Azure portal and either add units or bump up from an S1 to an S2 or S2 to 3.
Yeah.
Thank you.
Yeah. So just to kind of like roll back a little bit what Tim was saying, in case we didn't make it clear, like for solution accelerators, when you provision them, they get provisioned into your subscription. So when you go into Azure portal in a single resource group with the same name as your solution that you provisioned, you will see all of the underlying services that are running, and you have full control over them. You can scale them up, you can scale them down, you can delete them, you can add new ones. Like we provision into the customer subscription for solution accelerators, as opposed to central where we're deploying on your behalf into a fully managed SaaS offering, right?
Yep.
In your current architecture design, all the data that has been sent has the same priority, but there may be some devices that are mission critical and may want to have an out of band data processing or alerts raised. Do you have any recommendations, or have you considered these kind of scenarios? A lot of processing that your current architecture is based on kind of soft time constraints, wherein certain delay may occur at different, because there are a lot of moving parts, and so have you considered some kind of architecture reference wherein there are some time hard-bound time constraints?
Yeah, I think that
Like a low latency reference architecture or reference
Yeah.
implementation. Yeah.
I guess like the meta for that, or like what I would say is that what we've published in our reference architecture is, I would argue, a general guide for most IoT apps. We haven't, and we've talked a lot about it, and we will do it in the future. We will publish derivatives of it, and probably one of those derivatives will be around time sensitivity. The other one that oftentimes we talk about, Masashi and I have talked a lot about this, he was in here earlier, is very, very high scale. So sending many messages per second.
High frequency, yeah.
Yeah, high frequency, thanks. The thing I would probably say for what you're describing is it depends on what kind of time constraints we're talking about. Like if this is inside a factory and we need sub-second response, we're really probably talking about an edge device or Azure Stack, something that's inside there. We don't want to walk over the internet for something with that kind of time constraint, I would argue. What do you want to add, Juan? Go for it.
On the first part of the question where you asked about high-priority queues and things like that, inside IoT Hub there's a routing capability. And you can, for example, as the messages get propagated sent through IoT Hub, if you set up one of the declarative routes, then you can actually essentially forward that message to a different endpoint, like a queue, which essentially acts like a high-priority queue. And then you would essentially pull those messages out of the stream that then get forwarded to an event hub, for example. So you wouldn't get backed up by processing the event hub messages, and then you also get other benefits from the queue that you can leverage all the
Thanks. Juan's on our team, same team. I think I guess the questions that I would want to ask would be like how quick do you need that data processed? Like if it's if you truly need something sub-second, it's got to be done, I would argue, on premise. Like that's but if it's more like like Juan's describing, it's like I have a stream of data. It is coming to the cloud, so it's not that time sensitive, but I want to process it first. It's going to generate alarms. You could definitely use routes to place those messages in a different queue that ASA is prioritizing differently or maybe running over more frequently is probably where that's probably the path we would go down. I'm happy to chat with you about it more after as well. Okay. Yes, sir.
Can you guys hear me okay?
Now I got you.
Yeah,
You have to help me through this question. These architectures are pretty new for us. We have a large asset management system that lives on the control net, and it tends to collect pretty high-speed data, and that data has been stored on the control net for years. And our customers seem really reluctant to let that data move outside of that. And so we generally have to either reach down and get it or keep our applications down on that control net. Does that make sense? And B, do you have any thoughts on that?
Yeah, I mean, I talked to a number of folks they don't want to move their data to the cloud, either from a security or trust perspective. I think that's becoming more trodden ground at this point, and people are becoming more comfortable with that and the security aspects. With folks that aren't, we do offer Azure Stack that you can run on premise, would be one thought for you. If it's more like I can see many brownfield scenarios where, hey, my set of applications that's running inside of my business, it works great, but I want to take advantage of some of these new capabilities like Azure ML. I'm not that concerned about the data going off premise. Like it's fine for that data to go up in the cloud, but I don't want to mess with my existing applications. I want to leave them as is running. I think that sounds like kind of the path you're going down.
In large part, it kind of depends on your customer scenario too, right?
Yeah.
So like if what you're trying to offer your customer is analytics powered by the cloud, and it's less about command and control or real-time, interaction with the devices and the telemetry feeds, then, batching up that information or bulk uploading it to get that analytics win is also an option for you, where you don't have to have like a live feed to the things that are happening in that factory, but you still get the benefit of the cloud's compute. I mean, the other places where like this is a common customer scenario is like, hey, I'm running factories all across the world, and today I can optimize them individually, but ultimately I want, like, they're very similar, or maybe they're relatively identical. And so like leveraging that larger set of data gives me more impactful insights that then I can apply everywhere. And so the cloud is like an aggregation point in that scenario. And so like these are kind of the two most common reasons why, or ways you can advocate for leveraging the cloud. Like it's infinite compute, right?
Yeah.
Like, and it's also a bunch of services that will help you, garner insights and do analytics on your data that you would never be able to do on premise. And the other one is like, hey, now I can aggregate across, global endpoints, and I can get like insights that I would never have before, instead of depending on the factory, floor guy who knows everything and is individually tweaking that machine. Like now I can do that in the cloud, right?
Yeah, like I'm with, like just to, like, I think we're being flashed out of the room.
The silent
to
get
just
off.
say it where I think in part what Corey was driving is like, hey, if the data is on premise and you stay on premise, great. You could build some kind of batch forwarding mechanism
That
to
can
get it up
suck
into
it
the
up
cloud,
into the cloud. And
where you run your data analytics.
Yeah.
You want to pull it up to the cloud? I think that's doable as well. I could see a world where you're running Azure Stack local on premise, and you're running your analytics there.
Azure Stack. Okay,
Yeah.
cool. Thank you.
Okay, cool. Thank you. Okay, we're happy to chat and answer anyone else's questions. I think that we're kind of getting run off stage at this point. So thanks a lot for your time. Thank you.